Hello, students. Have you ever picked up a chemistry textbook and wondered why we use those strange letters like H for hydrogen or O for oxygen? These symbols are much more than just shortcuts. They are the language of chemistry, a system that helps scientists all over the world communicate effectively. Imagine trying to write out hydrogen in full every time we discuss it. It would take up so much space. So, scientists created these symbols to represent elements in a clear, concise way. But here's the thing, symbols are not just a way to write shorter, they carry important meaning. They represent both the elements and the atoms of those elements. For example, the symbol S represents sulfur, but it also tells us that each atom of sulfur weighs a specific amount, which is defined relative to the mass of a carbon 12 atom. So, when we say S, we are not just talking about sulfur, we are also talking about its atomic mass in relation to carbon. Now, how did we get here? Well, back in 1807, John Dalton, the father of modern atomic theory, introduced the idea of using symbolic representations for atoms. He used shapes like circles and squares, trying to figure out a way to represent each element visually. It was a start, but this system turned out to be a bit too complicated. Fast forward to 1814, and the great Swedish chemist Johannes Jacob Berzelius revolutionized the field. He introduced the idea of using the first letter of an element's Latin name as its symbol. For instance, Fe comes from the Latin ferrum, meaning iron. Au for gold comes from aurum. You can see how this system worked, and it quickly became the standard. So, what we use today, like H for hydrogen and O for oxygen, is the result of these breakthroughs, making our work in chemistry so much easier. Let's take a closer look at how these symbols are actually constructed. In most cases, the symbol for an element comes from the first letter of its name, and we write it in capital letters like C for carbon. But if that first letter is already taken, we simply add a lowercase letter. For example, calcium is Ca and chlorine is Cl. These symbols are not just for convenience. They also serve to simplify the way we write and understand chemical reactions. For instance, the reaction of hydrogen and chlorine to form hydrochloric acid, which is written as H2 plus Cl2 gives to HCl. Here, the H and Cl are the symbols, and we don't have to write out hydrogen or chlorine every time. It's fast, efficient, and universal. Now, let's talk about the metals, which have some interesting stories behind their symbols. Did you know that many metal symbols are derived from their Latin names? For example, copper is represented by Cu from the Latin word cuprum. Similarly, iron is Fe from ferrum, gold is Au from aurum, and mercury is Hg from hydrargyrum. This tradition of using Latin continues to this day, and these symbols are recognized all over the world. So, when you see Ag for silver or Pb for lead, you're looking at symbols that have been around for centuries, linking modern chemistry with its rich history. Symbols really come into their own when we start discussing chemical reactions. For example, let's consider the reaction between hydrogen gas and chlorine gas, which forms hydrogen chloride gas. In a balanced chemical equation, we write it as hydrogen gas plus chlorine gas gives hydrogen chloride gas, and it is written as H2 plus Cl2 forms 2HCl. By using symbols, this complex process is reduced to just a few letters, making it easier to understand. But it's not just about simplicity. These symbols allow us to balance equations, ensuring that the law of conservation of mass is followed. We know that the number of atoms on the left must equal the number on the right. Without symbols, this would be much more challenging to track. So, to sum up, Chemical symbols are much more than just abbreviations. They are the universal language of chemistry, allowing us to represent elements and atoms with ease. Thanks to the work of pioneers like Dalton and Berzelius, we can now communicate chemical ideas quickly and clearly, whether we are in a lab or a classroom. We also saw how the structure of these symbols makes our work easier, especially when dealing with reactions. And finally, we explored how symbols for metals have deep historical roots derived from their Latin names. I hope now you see how important and useful these symbols are in understanding the world of chemistry. They're not just a tool for scientists, they're the key to unlocking the mysteries of how the world works. In the next video, we'll discuss valency, radicals, and chemical equations. I'm excited to dive into those topics with you. See you then.